You are listening to the Information Security Innocent Podcast, episode 13, originally released on June 26, 2020. My name's Josh Amishav. This week we're going to talk about advanced passive reconnaissance, specifically a couple new tools we haven't discussed before, as well as a really powerful feature in Amass, specifically their scripting engine. Direct support for this podcast comes from BreachSense, the data breach monitoring platform. What's the easiest way hackers break into your network? By using valid usernames and passwords. Hackers collect millions of leaked credentials from almost daily data breaches. Without visibility into which of your employees or users' credentials have been leaked, it's tough to protect against this. Integrate BreachSense's powerful yet easy-to-use API into existing security solutions to prevent account takeover and stop online fraud. So the first tool that I wanted to discuss isn't really a tool. It's content security policy headers. So what CSP is websites can define in the response headers what other domains can inject code JavaScript into their domain. So this is meant as a cross-site scripting defense. So there's a great example on YouTube. You can look for injecting the Harlem Shake into various websites. And what it does is basically they open a website, open the dev tools, and then copy and paste some JavaScript kind of to pretend that they did this via a cross-site scripting attack, and then the website shakes and dances to the Harlem Shake. But the idea is that website owners can define who can run scripts, and then even if they have a cross-site scripting vulnerability, the CSP would lock down what actually domains could inject the script, so you couldn't just attacker couldn't inject the script hosted on one of their hosts, and they'd be severely limited to what could be run. So anyway, CSPs, besides for locking down as a defensive measure, they can also be used as a enumeration measure. So a lot of times you can find related domains or trusted domains from your target. And just as an example, if you look at HackerOne's CSP, it throws out errors.hackerone.net. So that'd be another subdomain that maybe we didn't know about before that we can enumerate via the CSP. Another tool I want to discuss is Trufflehog. So Trufflehog is a script you can run that finds things like SSH keys that are deep inside commit histories and branches within GitHub. So that's something you can automate pretty easily, and I'll throw a link to the GitHub repo in the show notes. Another technique that I want to talk about is URL team. So if you're not familiar with it, URL team is a group that collects. What they do is they brute force URL shorteners, right? So the idea is that if Bitly disappeared tomorrow, a large number of URLs would no longer work across the internet, right? Because they link to them and people using those shorteners. So they do is they brute force and create a mapping and have this publicly available data set that you can download and search. And one of the nice things is you can then see. And they do this, I think it's monthly or bi-monthly, maybe it's around that's a period. And then what you can do is you can unzip it and then grepper. I like to use RG. It's significantly faster for your domain. And then you can find both new subdomains you may not be aware of, plus web endpoints that you don't know. So now I'd like to talk a bit about Amass. And in order to get to what I really like to talk about, I want to talk about some other features that we haven't really discussed before. So one of the things that most people use, they run Amass, and it's using a lot of the default settings. So by default, Amass uses the configuration, depending on what operating system you are, it varies. So for example, on Linux, the Amass default configuration directory is under .config/Amass. Right, but you don't have to use that. You can use something a little bit more sensible, and you can override that via the -dir flag. One of the common complaints that I hear about Amass is that it takes too long. And one of the easy ways around this is if you want to define, if you're running a script and you've got other dependencies on this, and you need Amass to finish within X amount of time, you can use the timeout flag, right? So if you need it to be finished within 2 hours, then you can put just -timeout 120, it's measured in minutes, and then you know within that time span, no matter what, the script will finish. Okay, another important bit to understand is that by default, Amass will keep on cycling through every finding it has through all of its data sources until it can't find any more, and then it stops. But by default, it won't. It looks for proof that it should keep on looking, right? So for example, if you're looking for acme.com. You're searching for acme.com, and you come across ftp.acme.com. At that point, Amass will start looking for subdomains from the new subdomain that it found, like www.acme.com, or sorry, www.ftp.acme.com. And that's actually configurable. There's a minimum for recursive setting that you can set, that you can say how many instances does Amass need to find before it keeps on looking for new subdomains. So for example, if you know there's only a www.ftp.acme.com, but nothing else, then you may want to set that the minimum for recursive to 2, right? Because it'll find the first one, but you don't want to have it wasting time on finding more. So that's configurable, and that's often a good setting that you may want to add to your config file. I should also add that there's in the GitHub repository, there's an example config file that you could use to copy over into the directory that you create, unless you're using the default, and you can play with all these settings. So another thing I want to talk about is speed optimizations, right? So by default, Amass uses 8 DNS servers, right? But at some point, especially when you're coming from a single IP, some of those DNS servers are going to start throttling your requests, right? Because you're sending a large number of requests to them, and then your results are going to be heavily affected by that. So you can actually increase the number of resolvers pretty easily. And there's another project that we talked about a couple of weeks ago called DNS Resolver. And what that does is you give it a list of DNS name servers, and there's in the example they have one called public-dns.info, and has a list of thousands of DNS servers, and it goes through and it queries them to see which ones are valid. And then you run it, and it gives you a large list of around 9,000 valid DNS servers. Now, having said that, some of those DNS servers are still going to give you bad data. So you'll query, let's say you'll query ftp.acme.com, and it'll resolve, even though that doesn't actually resolve in real life. I haven't actually checked that domain, but the idea is that some of them are, even some of the resolvers are going to come back. They're going to be bad. You're going to have to weed those out. But then once you have that, you're going to have a large number of DNS servers you can use. Now, when you plug that back into Amass, you don't really need all 9,000. So you really only need, let's say, 25 to 50. So what you can do is you can just grab random. So what I do is sort -R, and for my out file, which is resolvers, and then I'll pipe that through tail and grab -N25. So I'll grab the last 25, and I'll put that into a file. Just one other thing to note with the DNS Resolver script, the example they give you runs 20 threads, if I recall correctly, in parallel. And then when you run the script, it takes, I think last time I ran it just with 20 threads, it took about an hour, close to an hour to finish running. So I highly suggest increasing that. I've run it with 200 without any issues, and it finishes within a couple of minutes at that point. So, but having an increased number of resolvers isn't enough. What you need to do next is when you run Amass, you need to adjust the max DNS queries, right? So by default, the max DNS query setting is set to 100, which means that Amass can have, each DNS server can resolve up to 100 domains at a time when it's doing, let's say, DNS brute forcing. But we want to increase that to each DNS server resolving between 500 to 1,000 at a time. So, for example, if we had 25 DNS servers that we got from our DNS Resolver script, so then we plug that back into Amass, we should increase the max DNS queries. Let's say we want each one to have 800. So then we'd say max DNS queries should be 20,000. So that's 800 times the 25 that we have, and that gives us 20,000, meaning each DNS server at any given time can resolve up to 800 domains. Now, another interesting thing to note, though, is so I did a comparison running when I added my 25 DNS servers to Amass, and then when I ran it normally when it only had 8, and it actually took longer. It took close to 4 minutes when I ran with 25 DNS resolvers, and when I ran it with the default 8, it finished in about 3 minutes. Now, an important thing to note, though, is that we talked about before, this Amass will keep on keep on every new domain it has, then it starts again running through all of its data sources to see what information it can pull out for that. So the interesting bit is when I ran with the 25 resolvers, I actually found more domain names, And then as a result of finding more domain names, Amass then needed to cycle back, do all of its lookups and searching the data sources for the new domains, which took longer, but ended up with a lot more information. So that's something to note and should be increased when time isn't a critical factor. Now, the most exciting bit that I really want to talk about was the scripting engine. If you're familiar with Nmap has NSE, right, the Nmap scripting engine, which allows you to add new functionality to Nmap, and it kind of turns it into a Nessus type scanning tool, or Mod Security, another great tool that has an embedded Lua engine. So Mod Security has a default rules engine if you're writing WAF rules, but then you want to do things that are more sophisticated, you can do that through the embedded Lua engine. So Amass also has an embedded Lua engine, and what they have is they call it Amass data source. So basically, they're scripts. They end the script name minus ADS, but then you can run other commands to help find more data. Okay, one of the nice things about this is that we've got lots of tools that we've talked about previously that can be used for domain enumeration. But then what we need in the end of the day, though, is we need to tie all that data together into one central point, ideally one central database that we can then do comparisons against to figure out what's new, as well as map it out, visualize it to make it easier to see patterns and to see anomalies. And that's where the Amass scripting engine really shines, because we can take other tools like Asset Finder, right, a tool written in Go, but what we can do is we can copy it over to our Amass directory. What we normally do is we create a new subdirectory called bin. Under that directory, we can copy the script over that we want to run, and then we can tell Amass to run this script, and I'll explain a bit about how we do that, and then take the findings from Asset Finder or whatever other tool we want to run, any new domains from that, and then inject that back into our database. Okay, so every ADS script needs to have a minimum of two things. First of all, we have the name. So we have a name equals whatever we call the name of the script, and then the type. And there's different types, ext for external. I mean, there's a whole list, and I'll link to the documentation, brute force scripts, scraping scripts. And what's really cool is that we can take the configuration file that we talked about beforehand, and when we can set up accounts that we have for various third-party APIs that we want to include in the data that Amass already checks for automatically, but we can also do for our own third-party tools that Amass does not have, and create our own scripts for that. And then we can put the credentials in the config file, and then the API library will automatically grab the credentials, and then we can use that within URL requests to query the APIs, or HTTP requests to query the APIs, and then grab the data, parse it, and then throw that back into our Amass database for further scripting. So besides for the name and the type, then there's two callback two functions that use. So one of them is the start function, and what that's normally done is to do things like we need to do for initial setup. That's most commonly used for the set rate limit function, which basically tells Amass how often it can run the script, so you don't DOS any of your third-party sources that you're querying. And the next one is the vertical function, and that's where you do most of the heavy lifting. But what I suggest is take a look at the /resources/scripts directory within the repo to get an idea, see some examples of how the scripts work, and that will help you hit the ground running. Okay, just to summarize today's episode, we talked about a couple of different tools and techniques you can use for passive reconnaissance. First was content security policy. So the CSP headers sometimes will disclose other subdomains or trusted relationships between the target and other domains. Trufflehog is a script that can be used to search deep within GitHub commits repositories to figure out other secrets like SSH keys that could be relevant to our target. And URL team is a archive that we can use to find new subdomains as well as web API endpoints. Web endpoints that can be used for further investigation that were used within URL shorteners. And finally, Amass's scripting engine can be used to tie all these tools together so that we have a central point of truth where we have all these various tools that are using to collect data on our target. And then we put that into one database, and then we can use that to compare to see changes over time, as well as to visualize to see relationships and anomalies. So if you have any questions or comments, feedback about this episode, please contact me at podcast@breachsense.io. And if you got any value from this, then please share it with a friend. See y'all next week.